welcome to another video. Today we will be taking a snapshot of a certain coin. So in this case, today we will be taking a snapshot of real USD. So meaning there's a real USD issuer account. And of that issuer account, we can see right now that this account was created. And if we look at the lines, so the trust lines, we can see here all the people that have a trust line to this account, and this is more or less the issuer account for RealUSD, so a token. And we will be creating a short program to take a snapshot of the balances, and yeah, that's the deal. So let's already get started. So we do know, for example, we can already create an address object called address, and also have to quickly change again, as always, into the presentation mode. So let's enter appearance, enter presentation mode. Yeah, there we go. And as always, the main is already, again, simplified to only this part here. So we are always starting from scratch. We just need a main class, and in the main class, we need a main method. And we've got only one line of code, and if you will, there's another variable. So these two things, that's all you need to get started here. Alright, then let's continue. So we're going to use the XRPL client, and then there's a method called account lines. Then this method wants the account lines request params object, so we're going to do that. And it's again a builder pattern. So in between enter, enter, we can also enter command here. And now we just need to specify a few things, or at least one thing. We need to specify an account. And in this case, I'm going to create it beforehand. Address equal real USD issuer equals address dot off, and then the issue address, and as you can see here, it's the RMX thing here. So I'm gonna enter it here. Alright, so real USD issuer, there we go. And then we can specify it as the account, and now we just need the ledger specifier, because from which ledger this snapshot should be taken. And then we're going to do the ledger index. So if we have a quick look at the live net again, we can see now that we can pick, you can see that there's always, every ledger has a number, and we're right now at 99 million or something like that. Yeah. Then we can define a certain ledger from which we want to take a snapshot from. And yeah, let's just take any number, I guess. So 99,500,000 we can take, or let's just use the current one. Let's use this ledger here. And then we just say off, and then we can define an integer. So there we go. And that's more or less already almost it. But an account lines, yep. And this account lines method gives us back an account lines result. So we have a look there again. Yeah, account lines result. It stated there. So account lines result equals that one here. Okay. So now we already well, a bit further. And the next part we're going to do is, obviously, let's just print out this account lines result. So this is not too difficult yet. So let's just start the main method. And we can see here right now, there are many lines that are being printed right now. Also 200, I think. We can see here there's a trust line for this account, and this this is a different account. Yep. And we can see here how much is owed. And then we can always see a certain currency. And now we obviously would have to translate that part here, because so every currency, so this is just in hex, the character value. In this case, all of these means real USD, but we can, yeah, there are utilities we can use to translate it. So that's also what we're gonna do. But for now, we are doing fine here. So again, if we have a quick look at XRP scale, we can see that real USD. If we also click on it, we can see that the let's go back again, or I mean to the tokens. We can see it here that the token code is down here, right? So that's here. No, never mind, this is somebody else. Let's go back. So this is obviously incorrect again to tokens, and now I'm correct here. So that one here, so somebody seems to create something similar, which was incorrect, but here, that's the token code. And the token name is RealUSD, and this token code RealUSD translates to that just in hex code. So let's take that even and just say string token code equals that one here. Okay, and then one part we're going to do is at the end of this, we're just going to do a loop for now. the account line result dot, and then I have lines here, and then we can say trust line, and then a double dot, and this one here, and then print just this trust and out. And what we can see is, however, that there now all the trusts are being printed out in a formatted way, so more or less. And we can see again the account, and then obviously we can do another check or already some filtering, because maybe we're even able to do it in the parameters here. Because can we define? No, we cannot. That's okay. Then we're gonna just do the filtering right here. So for example, we can ask if the trust line, no true trust line dot, and then we can say, well, currency dot equals, and then we can just say real USD issuer. And if it's not the case, then let's continue. Like then let's ignore it, because we want it to be the real USD, not the issuer. My bad. I mean the token code. Let's also say real USD token code. So it must. Well, if it's not equal to the token code, then we will skip this iteration and ignore it. Right. So right now, when I start again, now we're printing only out the accounts that have real USD with this account in this line here. And now if we look at it, it's always going to be the currency here, real USD. And then the next part is obviously now we can also just minimize it a bit. We can just say trust and dot account in this case, and then we can just print out the balance, for example, exactly like that. And then if we start again, we can now see all the accounts here in a nice way. We can see how much holdings each account has. So right now this is the opposite way, because this is how much is owed, if I'm not mistaken. Because if we look here, so we can just verify this quickly. We look here to trust lines, for example. I'm not sure if it's automatically like the same way arranged, but it seems like it. So we can rather see the minus 0.02. Then we can see the minus 265. So we can see this is more exactly how it should be. And the interesting part is if we, for example, click with one of these accounts here, because it says minus 2.65, then here it's the other way around. So here this would be obviously like a balance. Yeah. So this is the other way around. So from the issuer account, it's a minus because this is owed, right? So if you have a trust line, and this is just saying, well, that's how much this account owes to the following accounts. That's why it's negative. And yeah, so this looks already pretty cool. And right now this ends but at one page. So now we have to adapt the logic just a little bit. We can also make another message, obviously. Let's just say int ledger index equals that one here, and then we can use obviously ledger index here, and then we can also make an output or format, and then taking a snapshot of ledger %d \n ledger index. Yep. And then obviously when we start, then it also gives us this message here first, taking a snapshot of ledger whatever, and then we can see all the balances for now. The thing is, this only gives us it for one page. So we can see here, we can even set a limit. I think the limit is at the max 200 results in this case. And now the difficult part is we have to paginate, right? So we have to go to the first page. So literally what has been programmed here, go to the next page, and next page, and next page. So right now they're doing it here at well, they can offer different paginations, but I think the XRPL4J only allows 200 as a maximum, I think, but we can still try. And specify the limit here, and we can say, for example, 200, right? So in this case, it wants an unsigned integer, so let's provide an unsigned integer dot auth or whatever value of 200. So this should probably be the same thing. It's by default 200. Or it's even 50 only. Nah, 200 seems to be fine. I would have to check the APIs for that, but it's not too important right now. So let's go to the more interesting part. Is obviously like how the pagination works. And this is the only small part that's a little bit difficult but not really. We just access the account lines result, and then there's an object called marker. We have to use that. So the marker tells us where we can continue to paginate. And in this case, we're gonna create something interesting, because we're going to create a do while. So do, and then put this entire thing into a while. Yes, and then say while, And now we also need to put this first querying. We can also do it inside, but yeah, we also have to define it outside, unfortunately, like before the do. Because now, okay, let's do it that way, and then we can redefine it. And now the interesting part is that we have to, oh, even not, let's not even work that way, that's my bad. Let's keep it that way, but we need the marker actually. We need the marker, yeah, we need the marker equals null. And then we're gonna say that marker is all fine. So hopefully this also works with a null value. I hope this is allowed. And then let's go to the difficult part at the bottom, while marker not null. While the marker is not null, we shall continue. And after we did this request here, then we're gonna change the marker to marker equals account without the marker, because it does give us the marker dot get, yeah, because and also get, or the can say get, I must say, or else, yeah, I have to do it that way because we literally need the null value. And let's quickly test it if this does anything, or if it crashes immediately. No, it crashes immediately because I first need to check if I can pass it. I can even pass it to optional in this case. Well, let's try that, I guess. I'm gonna wrap it in optional, so sorry for the mistakes here. Optional, but empty. Let's see if that works. Now that would be a deal. No, I did a mistake. Never mind yet. The marker. Let's see if it now works. Okay, this looks not correct. And also I might have to delay it a bit because too many requests. So let's do something very simple. System dot thread dot sleep, and let's just wait like 1 second. Okay, so because this is too many requests, like that, I'm just not happy about that. So let's wait 1 second to get the next 200. So we're gonna get the first one and the next one and the next one and the next one, and that way we're right now more or less taking a snapshot. So now, right now we're paginating through it. We can obviously enhance the messages a little bit. And we could, for example, also write it to a file. So let's just do a simple thing here. It's just, so you can see right now it's taking a snapshot. I'm going to quickly pause it again. It's one very simple thing. It's just create a file writer. A file writer is not very, a buffered writer. Called buffered writer equals new buffered writer, and then in that we say new file writer, and then we provide a file. So let's say snapshot.txt. Right, so it's not too difficult. And also add the method signature. Like I said, I'm not encapsulating it, just doing a throws here because just for the purpose of making it easier. And then after the system of print line, we can also do it one more time. We can write it to a file. We'll just say buffered writer.write, and then what are we writing? Literally the same thing here, trust and account. And then we shall, for example, do with a double dot for having a CSV file like thing. And I think to write, yeah, this is perfect. And after this line, now we're also writing it to a file. So now if we just do a quick start and say run again, we can now track a new file being generated here. Like here, it should just show up in a few seconds. I should have also closed the file at the end, which would be ideal. So at the end of the program, we should say file writer, buffered writer.close. So this would be clever. But let's see, I think it auto closes anyways, but still, this is not good. So let's wait a few seconds. So right now, this just goes over it. And I'm going to quickly pause. And now I'm continuing again. And one thing you can see, this already snapshot.txt file. And I did a coding mistake because right now I wrote down the token. I obviously have to change it to balance and not... so delete, ignore, we don't need to save that right now. And I obviously meant to write, yeah, that's what you get when you don't look closely at it. Let's go there, and obviously we wanted to write balance and not account. Yeah, so literally the same thing here, and start it again, and now we're good to go again. And what we can see now is again the snapshot file being generated here, and now we can see the balances, and now we can see you can scroll down. I think it was 78,000 trust ins, so you can see it's going to take a while. So this is a buffered writer. So every now and then when it has whatever enough characters, it's going to be printing it out here. And yeah, and that way it just takes a short while until it processes all of it. So I think it was 78,000 trust, so yeah, obviously it takes a little bit longer now. But yeah, that way now we created a simple tool that can create a snapshot at a certain ledger height. And yeah, thanks for watching and see you in the next video.